Asked to solve equations like these, we need to realize that we've got some algebraic fractions and we want to deal with the fraction part of these types of equations before we start to solve them. So in number 1 we've got 6 equals 7x minus 4 over 3. So this part here is a fractional part. In order to deal with that, this is divide by 3, so if we multiply that side by 3, that will get rid of the fraction part. Remember, when solving equations, whatever we do to one side of the equation, we need to do to the other side as well. So if I multiply this side by 3, I need to multiply that side by 3 as well. When I do that, these two cancel, and on the right hand side I'm just left with 7x minus 4. On the left hand side of the equal sign I'm left with 18, so 3 times 6 is 18. Now with these equations we want to isolate x, get x all by itself on one side of the equal sign. So looking at this here, I can see I've got minus 4. So opposite operation of minus 4 is adding 4. So effectively we're adding 4 to both sides. So on the left hand side we get 22 equals 7x, and then it's just a matter of dividing both sides by 7. So if I divide this side by 7, divide that side by 7, these cancel and I'm just left with x is equal to 22 over 7. You can just leave your answer like that, that's fine. Okay, number 2, tad bit more complicated. We've got a whole lot of fractional parts here, but just have a look at the denominators. We've got 3, 5 and 2. So we want to find the lowest common multiple of 3, 5 and 2. So what number does 3, 5 and 2 go into evenly? And we want that number to be the lowest. So you could just go 3 times 5 times 2. That will give us 30. That is the lowest common multiple of 3, 5 and 2. So we could multiply right through by 30. So 30 multiplying that, 30 multiplying that part, and 30 multiplying that part. So I'm not changing the equation, but I'm trying to deal with the fractional part. So what we've got here is 30 divided by 3. So we end up with 10 at the front of x minus 8 minus, then we've got 30 divided by 5 will give us 6 at the front of 2x minus 1 equals 30 divided by 2, excuse me, or 30 times a half will give me 15. So the strategy here when you're faced with equations like this is to find the lowest common multiple between 3, 5 and 2, or between the denominators, multiply through by that number, and then that'll deal with the fractional part. Now let's go ahead and expand now. So we want to expand. So we end up with 10x minus 80. Then this will become, that minus sign belongs to that 6. So we could in a sense say that this is negative 6 minus, negative 6 times 2x will give me minus 12x. And then this is negative 6 times negative 1. So that becomes plus 6 there. Rewrite the rest of the equation. Then we're simplifying. So finding the like terms, got my 10x minus 12x will give me negative 2x. And then I've got minus 80 plus 6. That will give me minus 74. That is equal to 15. Okay, now it's getting a little bit simpler. I want to add 74 to both sides. So you end up with negative 2x is equal to, so those to cancel, 15 plus 74 gives me 89, and then dividing both sides by 2, by negative 2. So x is equal to 89 divided by negative 2, which is just negative 89 over 2. Okay, the final problem is a word problem. So we've got Mark worked twice as many hours as James. If James had worked another 48 hours, he would have worked twice as long as Mark. Write an equation and use this to find how many more hours Mark worked than James. So with these types of problems, you want to decide on some variables and then let each of those variables equal something. So we can let m equal the number of hours Mark worked, and then let's make j equal the number of hours James worked. Okay, so with these sorts of word problems, if you're trying to solve it, you should come up with your variables, okay, and just write a little key like that. So go back to the question. It says Mark had worked, so Mark is equal to, Mark had worked twice as many hours as James, so twice j, so 2 times j. And then what have we got? If James had worked another 48 hours, so now we're thinking about James. So the number of hours that James worked is j plus 48. So he's worked another 48 hours, so let's just write j plus 48. He would have worked twice as long as Mark. So j plus 48 is equal to 2 times m. So let's simplify these equations. So this one, m is equal to 2j, and then this one, j plus 48 is equal to 2m. So we've got two equations, so we can, with two unknowns, and these become simultaneous equations, so we can solve them simultaneously. So simultaneous equations. You may need to revise all the different ways that you can solve simultaneous equations. Okay, so I know that m is equal to 2j. So what I can do is substitute m, so this equation, this top equation here, into the second equation. So when that happens, I end up with j plus 48 is equal to 2 times m. Now, instead of writing m here, I'm going to write 2j because m is equal to 2j. So 2j there. So I'm just substituting. Then some simplifying. 2 times 2j is 4j. And notice that this equation here only has one unknown. So you can go ahead and solve it now. So I've got j on both sides. I want to get them together on one side of the equal sign. So I can minus j here, doing the same thing to both sides of the equal sign. End up with 48 equals 3j on this side. And then dividing both sides by 3, you end up with j being 16. So that means that James worked 16 hours. 16 hours. And we can work out from one of our original equations, if James worked 16 hours, then Mark would have worked 2 times 16, which is 32. Okay, we haven't finished the question yet. The original question asks us how many more hours did Mark work than James? So Mark worked 32 hours. So our final answer is Mark worked 16 more hours than James. So you definitely need this final sentence here.